Hello friends, welcome to this lecture on computer-aided power system analysis. We have been discussing the process of building the Y-bus matrix for an unbalanced three-phase network. So, let us continue. So, what we have done is that we have taken a simple 4-bus 4-line system and we have also drawn its equivalent circuit as shown. Now, with this equivalent circuit, in this equivalent circuit we have already indicated all these voltages as well as the currents, and also we have talked about the various impedances as well as the admittances. And now we are ready to start writing the equations, but before we start writing the equation for this entire network, we should first talk about that how to write down the equations for individual current in the series branch as well as the individual current in the shunt branch, because once you understand that how to write down the equations for the individual currents in the series branch as well as the individual currents in the shunt branch, then we would be able to write down these equations for this entire network. So, let us consider again as usual, which we have already shown, that a line between bus M and N, and that particular and in that line bus voltage at bus M is given by Vm ABC as well as at bus N is Vn ABC, and here Imn ABC, and here let us say that we said that it is Imn shunt ABC. So, now let us try to write down the equation for these two currents. So, now what we have is we have VMA. If I write down in the matrix form, VMB, VMC is equal to or rather if I apply this KVL, minus VNA, VNB, VNC, that is obviously would be given by, so this voltage minus this voltage would be obviously given by this total drop in this series branch, and this total drop in the series branch would be given by Zmn ABC. So, that is equal to essentially Zmn AA, Zmn AB, Zmn AC, then Zmn BA, Zmn BB, Zmn BC. That is the convention we have taken, yes. And lastly Zmn CA, Zmn CB, Zmn CC into IMNA, IMNB, IMNC. What is this quantity IMNA, IMB, INC? So, we write that IMNP is actually the complex current flowing in phase P of the series branch of the line between the buses M and N, and where of course P is equal to phase A, phase B, phase C. So, here when we are writing that this is IMN ABC, so we must note now, probably we are now sure that when I say that IMN ABC is actually a vector, and this is Imn A, Imn B, Imn C transpose. So, this is again a 3 cross 1 transpose. So, then therefore, this equation can be written as, so this equation can be written as Vm ABC minus Vn ABC is equal to Zmn ABC into Imn ABC. So, then therefore, Imn ABC is equal to Zmn ABC inverse because it is a 3 cross 3 matrix inverse into Vm ABC minus Vn ABC. So, we call it, let us say, Ymn ABC into Vm ABC minus Vn ABC. So, that is the expression of the current Imn ABC. We note that Ymn ABC is Ymn ABC, we note that Ymn ABC is Zmn ABC inverse. So, this is a again 3 cross 3 matrix, right. So, this is the expression of Imn ABC. So, this is the expression of Imn ABC. Now, what is the expression of current Imn SH? Again you will note. So, basically we note that Imn shunt ABC is equal to Imn shunt phase A, Imn shunt phase B, Imn shunt phase C. So, these are the 3 individual currents transpose, this is a 3 cross 1. So, essentially what is happening? Essentially physically what is happening, that I do have a line between bus M and N, So, physically there are 3 lines, right. So, this is phase A, phase B, phase C, phase A, phase B, phase C. This is bus M, this is bus N, and we have already denoted that, well, there are impedances individual and also there are impedances, mutual impedances between any 2 phases. On top of that, there are also shunt half line charging susceptances or shunt half line charging susceptances between any phase and the ground, Now, because of their proximity, I mean they will have their individual admittance, and also because of their proximity they will also have their mutual admittance between these 2 and these 2 as well as these 2. So, then so this and again. So, this is it. So, when we are saying Imn A, so Imn A is actually this current. So, when you are saying that it is Imn A, so Imn A is actually this current, Imn B is actually this current, Imn C is actually this current, and when we are talking about Imn SHA, this is Imn SHA. So, this is the shunt, this is Imn shunt for B, and this is similarly I Mn shunt at phase C. So, these are the 3 currents we are talking about. Similarly, also there are 3 currents here. So, similarly there are also 3 currents here. So, basically physically this is the case, right. So, we have just now derived the expression of these 3 currents in terms of these 3 voltages and as well as these 3 voltages. Now, we have to derive the expression of these 3 currents in terms of this voltage and as well as the admittance matrix. Now, if we look at this, obviously the current here because it is a shunt current, it would be something like this voltage multiplied by this admittance, but because this is a 3 phase voltage. So, this is a 3 cross 1, there is a 3 cross 3. So, then we can simply write down the equation is I Mn SH A is equal to I Mn SH B and I Mn SH C. So, this is a 3 cross 1 matrix and this would be Y Mn SH A, Y Mn SH A B, Y Mn SH A C, Y Mn SH B A. BC YMNSH CC into VMA VMB VMC. Right. So, this is a 3 cross 1 vector, this is a 3 cross 3 matrix and this is a 3 cross 1 vector. So, this is true. So, we write that IMNSH ABC is nothing but YMNSH ABC into VM ABC. So, this is the relation between the bus voltages, this bus and this current. So, similarly the current here would be, if I say that this is IMNSH ABC at this stage, it would be, and this current would be nothing but YMNSH ABC into VN ABC. So, let us say this current would be nothing but, so this current I can write that this current would be nothing but YMN SH ABC into VN ABC. So, right. So, with this background, so now we are ready to write down the equation for this entire system. So, we write down the equations for this system. So, equations for the complete system. So now here we have already shown that if I take this injected current is equal to ultimately this current plus this current plus this current plus this current. So, then therefore, we can write down that I1 ABC. So, I1 ABC is equal to, you can write down that now I1 to SH ABC is nothing but Y1 to SH ABC into V1 ABC. Now, here we can write that I1 to SH ABC plus I1 to ABC I14 ABC plus I14 ABC plus I14 SH ABC plus I14 shunt ABC plus I14 ABC. So, this is from the applying KCL. Now, I12 shunt ABC is nothing but Y12 shunt ABC into V1 ABC. I12 ABC would be Y12 ABC into V1 ABC minus V2 ABC, right. Y12 ABC is similarly I14 shunt ABC would be Y14 shunt ABC into V1 ABC. Please look at this. If I look at this, because this shunt branch is also ultimately connected at this branch. So, then therefore, I14 SH ABC would be this admittance into this, this admittance matrix into this particular voltage vector plus it is I14 ABC is Y14 ABC into V1 ABC minus V4 ABC. So, then therefore, if I now take all these V1 ABC terms together, so Y12 SH ABC plus Y12 ABC plus Y14 SH ABC plus Y14 ABC, there should not be any comma here, Y14 ABC. So, this into V1 ABC minus Y12 ABC into V2 ABC minus Y14 ABC into V4 ABC. So, this is equation 1. Here we note that Y12 ABC is actually Z12 ABC inverse and Y14 ABC is equal to Z14 ABC inverse. So, this is at bus 1, this is at bus 1. At bus 2, so at bus 2 what would be the currents? This is at bus 2. At bus 2, if I look at this picture, I2 ABC would be equal to this current plus this current plus this current plus this current. So, we can write down I2 ABC is equal to I2 ABC is I21 shunt ABC, I21 ABC, I23 shunt ABC and I23 ABC. So, at bus 2 I2 ABC is equal to I21 shunt ABC plus I21 ABC plus I23 shunt ABC plus I23 ABC, right. And I21 shunt ABC would be nothing but Y21 shunt ABC. In fact, it should be Y12 shunt ABC because Y12 shunt ABC because this same admittance is connected. So it is y12 shunt ABC. So we should write y12 shunt ABC into V2 ABC plus y12 ABC into V2 ABC minus V1 ABC plus I23 shunt ABC is y23 shunt ABC into V2 ABC plus y23 ABC into V2 ABC minus V3 ABC. We again note that y23 ABC is nothing but z23 ABC inverse. So therefore I2 ABC is equal to minus y12 ABC V1 ABC. So it is minus y12 ABC into V1 ABC plus y12 shunt ABC plus y12 ABC, sorry, y12 shunt ABC plus y12 ABC plus y23 shunt ABC plus y23 ABC, that is equal to V2 ABC minus y23 ABC into V3 ABC minus y23 ABC into V3 ABC. So this is equation 2. At bus 3, what we have? So at bus 3, if I apply this same principle, I3 ABC is equal to I32 shunt ABC plus I32 ABC plus I34 shunt ABC plus I34 ABC. So it is I32 shunt ABC. So it is I32 I3 ABC. It is I32 shunt ABC plus I32 ABC plus I34 shunt ABC plus I34 ABC. I32 shunt ABC is, so it is y23 shunt ABC into V3 ABC plus y23 ABC into V3 ABC minus V2 ABC, and this is y34 shunt ABC into V3 ABC plus y34 ABC into V4 ABC. So then therefore I3 ABC, if essentially V2 V4, so it is minus y23 ABC V2 ABC plus y23 shunt ABC plus y23 ABC plus y34 shunt ABC plus y34 ABC to V3 ABC minus y3 4 ABC into V4 ABC. So, this is equation 3, and we again note that y3 4 ABC is equal to z3 4 inverse. Right. Similarly, at bus 4, very quickly if we write at bus 4 I4 ABC is equal to I4 ABC is equal to I41 shunt ABC plus I41 ABC plus I43 ABC plus I43 shunt ABC. So it is I41 shunt ABC plus I41 ABC plus I43 shunt ABC plus I43 ABC, sorry, I43 ABC, I43 ABC. So then therefore I4 ABC is equal to Y14 shunt ABC into V4 ABC plus Y14 ABC into V4 ABC minus V1 ABC plus Y34 shunt ABC into V4 ABC, Y34 shunt ABC into V4 ABC plus Y34 ABC into V4 ABC minus V3 ABC. So if I take them together, so I get minus 14 ABC V1 ABC minus Y34 ABC into V3 ABC and plus Y4 shunt ABC plus Y4 ABC plus Y34 shunt ABC plus Y34 ABC into V4. So this is equation 4. So you see we have got all these 4 equations here. So now what you have to do, you have to now write all these 4 equations in a matrix form and then see what kind of conclusion we can draw. This we will do in the next lecture. Thank you.